Our next presenter will be Mike Conway and Deep Patel from the NIEHS. Their title is the NIEHS Data Commons.
Hello everyone, my name is Deep Patel and along with me is Mike Conway. We work at NIEHS for Office of Data Science. I would like to we have some of our team members over here. I would like to introduce them. Stephanie is over there, if you can just wave from there. Maria is there, Charles, and Sue. Okay, so let's go further with that. So our main mission of Office of Data Science is to accelerate scientific discoveries along with research projects and to use those data to improve public health and which are related to environmental health science. So in some of the following slides, I will be discussing about some of the common objectives. So in the start of the commons, we started using internal researchers and their data generated using next-gen sequencing. We also use some of the organizational policies to handle the data life cycle and to track the provenance and the relationship of the data sets. To manage the metadata for the discoverability, metadata, we are trying to follow the FAIR principles, which is findable, accessible, interoperable, and reusable. Obviously, so the metadata are for the metadata, we standard metadata along with controlled vocabularies, which can be in different using Synaptica and different ontologies as well. So this metadata are being added to the data along with in an automatic way through the pipelines, and so the data generated from instruments from different sequencers are ingested using pipelines and computer actionable policies into the iRods, which are then indexed using indexers. Right now we have integrated Thunderstone indexer, which is a in-house of organizational, but in future we are planning to extend it to Elasticsearch and triple storage. This metadata will be used and to directly generate in a template way, and which can be used for the publication in Ncbi Geo or other publications as well. To support integration and use of so data which is in commons, which it will be easily discoverable and can be used for different common tools from commons itself. Right now, the commons is just for internal usage for internal NIEHS users as of now, and data is securely shared. The generated data inside the commons can be shared with different researchers, and that those data can also be audited, and different policies can be enforced using iRods, and the data can be authenticity of the data can be maintained using provenance, and it will be easily reproducible. In the next slide, this is the high-level infrastructure of what NIEHS Data Commons will be. You can see on the far left there are scientific community which can use different data commons APIs to add their research data into storage, which will be maintained using iRods. The big circle in the center is the iRods zone, and different data tools and discovery environment will be provided, which can be used to access those data and as a workspace and work on it. So the data will be secure and compliant using the FAIR principles, and all the metadata will be assigned the global unique ID to make it persistent, along with and it will be also used to index the data stored inside iRods, and it can be, maybe in future we can coordinate different APIs with the big NIEHS data commons, which will be really useful to both of the organizations. And further, Mike will be.
Thanks, Steve. So we were just at Bio IT World, Maria and I, and kind of tying into what Stan Ahalt's comments this morning about the NIH Data Commons. This is what we're really trying to prepare for within NIEHS. And when I was talking to Stan this morning after his talk, how many of you guys are familiar with what's going on with the NIH Data Commons first? So this is something that, yeah, Cesar is. So this is something that Ncbi is really involved in, and iRods is really involved in, and I think it's a really great opportunity. And when I was talking to Stan, what we've seen, our readout of the NIH Commons is reflected on the slide, and this is a Regan Moore slide that I use over and over again, where he has this conceptualization of a research data lifecycle. And the NIH Commons is really focused on the sort of right hand of the spectrum where you already have prepared published research collections where they're immutable and DOIs have been assigned. And there are lots of people trying to play in this space, but we're actually living over on the left-hand side of this chart right now, which is the sort of formation of these collections. So when we have researchers who are doing projects, they might have research subjects in terms of they're either sequencing human DNA or animal DNA according to studies, and they're doing all kinds of different assays and tests using next generation sequencing or mass spectrometry or all kinds of other experimental methods to gather data. And these data are associated with projects, and we're really concerned here with internal data and gathering scientific data coming from all our research cores and essentially delivering it to the PIs so that they can start doing their analyses. And this is the area where we're really working on, is just trying to get a handle on this internal data flow. So we have, for example, big DDN storage where we just have piles and piles of sequencing data that we really don't have information about. So there's a lot of data loss that's going on. And so this is internally us trying to start getting a handle on the data quality upstream before it even hits something that you might even call the NIH Data Commons. And this is, to me, the big opportunity that we have here with iRods. Is it's really the only thing I know that allows you to sort of have your data, to sort of start applying your data management policy so close to the source of the data, and we're finding that's really important. The concerns that we have within the NIEHS Commons right now are the upstream metadata quality and getting data out of our core labs and getting it into the hands of the PIs, and then appropriately sharing that data within the project. Okay, so this is way before NIH Commons would even see anything. And the organization Office of Data Science is also part of this effort to start defining the data management policies within our organization. So we have a lot of opportunity to sort of combine this technical infrastructure and the policy enforcement mechanisms that it contains and apply that towards these emerging definitions of even our own organizational data management policies. And frankly, within NIEHS, we're also just as interested in what data can we throw away, because there's also this practical storage management aspect. And then as we transition into what the larger NIH Commons is pursuing, they're interested in fair data and publishing and data sharing, but again, all that relies on having good quality metadata upstream, and that's really, again, where we're living, and where iRods is also just as important. Okay, so one of the things we wanted to talk about is patterns, and this is something that we've really like to see coming out of the consortium now. Sometimes we talk with Jason and Terrell and those guys about sort of what are the next kinds of things to talk about with iRods, and I've kind of told Jason is you really need to start making fair noises, because iRods has all the raw materials, if you will, to create fair fair data repositories. And with iRods, since it is such a somewhat abstract middleware platform with a lot of different capabilities, the trick here really now is to sort of assemble and think about these capabilities in a way that we can deliver these kind of fair data solutions. So, you know, the questions we have coming here is how can we, as a community, develop these frameworks around the iRods capabilities and sort of put them in this sort of fair mode. And do we see like a developing language and architectural patterns, a set of architectural patterns that allows us to start talking about commons in the way that we see a lot of these things sprouting up? Okay, and so the consortium is already developing a pattern catalog, if you will, and you know, our notion is that this is a good thing. So within NIEHS, what we tend to have are a lot of different cores that have different kinds of instruments, different kinds of ways of analyzing data, and they exist on these science VLANs. So they tend to be the instruments and the storage and compute resources within each of these labs, you know, sort of circled off in a VLAN. And then we have the central zone, and conceptually one way we want to look at this is to start extending storage resources into these science VLANs and start using some of the tiering kinds of approaches that Jason, I think, will demonstrate some. Yeah. So we saw the tiering mode and immediately thought that we could start treating some of these science VLANs as data tiers. So we're interested in applying the pattern of tiering to gathering data from these core labs. We also have places where that won't work. So this file scanner and this data ingest pattern that the consortium has identified also is something that we're starting to want to apply for our own purposes. We also have an operating landing zone. This was originally done by BioTeam before we got to NIEHS, and we're working on this now, but it's the notion that we have data in the labs that can come through Clarity, and then we do pre-processing of the data. We do initial QC and deliver the data into the commons through these pipelines and start gathering metadata. So again, it's the upstream data quality. We're working right now to integrate with the Clarity limbs so that we can start getting sample data, start getting information about the experimental procedures used, and start pulling that in. Because again, you can't have fair data unless you accumulate accurate data. The NIH Commons is also very much concerned with distributed workflows. So we are switching to CWL and Nextflow and starting to look at those kinds of tools. And I think Clarice is going to talk tomorrow about the sort of way this overlaps with how we want to have a cloud compute strategy in the future. So we're really focusing on CWL and Nextflow right now and gathering procedure and provenance metadata going along. So the data to compute and compute to data notions are things we're already applying internally. For metadata support, this is another area where we're working, and I was trying to give a plug to the metadata working group. So here's where we are. We have our scientific communities, and we're participating in this metadata templates working group. The notion is that metadata templates allow us to create structured data out of AVUs and also apply validation, things like that, and integrating that with selecting some sort of control vocabulary ontology server and establishing vocabulary standards across NIEHS. And we're working right now on marrying these things together so that we can start curating data, including with human curated application of control vocabularies. We're interested in AI and machine learning also for classifying data. So these are ongoing activities. And putting that into our zone. Okay, the other thing that we're doing right now is looking for standardization of indexing. So right now we're indexing into Thunderstone, which I'd never heard of, but which is sort of a Google appliance. And the thing that we're doing now before we can get to Elasticsearch, and also looking at semantic metadata and triple stores. So we're interested in participating in groups that are building sort of these standardized frameworks for, and I know Tony's here from Cyverse, and so they've been a model that we've used in terms of combining both background scanning and crawling with near real-time maintenance of indexes using AMQP-based mechanisms. So That's an area that we would like to be active because we really see projecting different parts of this grid into different sort of storage resources. And then tied into metalinks, we've been talking a lot about this notion of virtual collections, which is another pattern. And I've seen it cast in multiple ways, including the idea of query arrow. But this is the notion of trying to break out of the IROD's hierarchical view of data, which, if you know the catalog, is just as much a lie as if you try to create different kinds of collections based on metadata. It's all lies. So what we want to try to do is standardize the way that you can form new collections across even federated zones. And for example, instead of querying the ICAT for parent-child relationships, instead query Elasticsearch or a triple store. Return things in a standard format that looks like an ILSLA and then represent those as collections within the commons. And so that's what we're going for. And we kind of turn that virtual collections, and that's kind of like this last link in the chain that we're working on right now. So what we'd like to be able to do, again, is see a federated zone, push data into indexers using this yet to be determined sort of formalized indexing framework, and then apply standard virtual collections to, again, so for example, creating a collection that spans all the different kinds of assays done on a particular sample, or a collection based on a PI or a certain project ID. You know, these are simple things, and again, IRODS has the raw materials, but we also want to protect our investment because we cannot be a software development shop. We can be a shop that cooperates with other software developers, and I think this is really the thing. I think I've said this for like five user group meetings running, but we're really looking for sort of the force multipliers as we see these commons proliferate. And I'm probably running out of time, so somebody give me a signal. Yeah, we're okay. So as we see these commons proliferate, how are we adopting the same language on patterns? How are we identifying them? How can we take these things and turn them into raw materials that are available to other developers within the IRODS platform? Because we see that as a force multiplier. So let's see what I have. Yeah, so we're looking at some of the things that are coming out of the NIH Commons. They seem to be really focused on BD-BAG and JSON LD as a way of representing packaged data, you know, data that's made immutable, packaged, and assigned a persistent identifier. A lot of the Commons efforts I've seen, like NCI, they actually really seem to be more about shared authentication and authorization using OpenID and OAuth. And so that's something I think that we're really going to have to struggle with. Let's see, here's the thing. So we want to build a Commons, but what you see, and we saw this with DFC2, is, well, this all sounds great, but I don't want to change anything I'm doing. I don't want to change any way that I'm working right now. So how can we sort of take these advanced systems and get them in the hands of users? And so that might mean meeting users where they are. So what kinds of new command line utilities do we need? What kinds of, you know, we have in our mind little languages and little DSLs that you could use in different things like Jupyter that can help you discover data, interact with it, tag it with metadata. But how can we do this in a regular fashion? Because we sort of don't have the horsepower to build all this custom. And I think there's a lot of that happening. And it's right. I think we're still in the let a million flowers bloom. But at some point, how can we start forming this into a discipline in a common language? I threw this in here just for the heck of it, because when IROD started, we actually started working for NARA. And this has just been near and dear to my heart. We don't talk about it enough. But big data is actually still really big preservation, right? So our roots are actually, back in the day, really more in long-term archiving and data preservation. And one thing I kind of miss, because I always thought it sounded kind of cool, was all the OIS language and the archival concepts. So while we talk a lot now about FAIR and cloud, and there's still the sort of the latent cyber infrastructure for the 21st century NSF sort of frame to what we do, I also want to bring back, you know, OAIS and digital preservation is actually core to what we're doing. Because what we're finding is, you know, we're preserving the metadata to discover, but as I say, FAIR doesn't matter if the data is lost. And so I think that that's another thing that, if you will, is a selling point or a strong point for IRODS, is actually built for trusted digital preservation. And while we may have fancy tools out there now that can do distributed workflows and so forth, they don't have the story about the sort of ability to help you manage your operational research data, help you get rid of data you don't need, help you move data to compute, move compute to data, and also to do this long-term preservation. So that maybe sounds more like a grab bag of points. But I have to tell you, when we were at BioIT, we met more people building data commons just standing around our poster in the hall. And I think Terrell and Jason, I think you guys saw the same thing. So there are groups at GA4GH that are potentially forming to sort of talk about standardizing data commons. It's become like the new cloud, I think. So with that, I think we can wrap up.
Certainly someone has a question for Mike.
What did he just say? What is he
Yeah, what is he talking about? Here you go.
Okay, thank you for a nice presentation. Well, we are working on FAIR principles as well in Maastricht, so that triggered my attention. What I was wondering, did you already think about technologies that you use to, do callouts or lookups to ontology services? You mentioned that you will use vocabularies in your metadata, but how are you going to present this to an end user?
That's a really good question. And so, Maslow's hierarchy, we're still low on the hierarchy. So I think what we're interested in now, the short answer is we'll sort of figure that out when we get there. The short answer is right now we're working on selecting our back-end services to manage and do our vocabulary engineering. The second thing is we're really looking towards tools for curation, so this notion of metadata templates and doing things like saying these collections should be marked up with vocabularies from these ontologies and have that be part of the user experience is another stepping stone, if you will. We're working with metalinks as an example, and one of the notions we have, or one of the first changes we did to metalinks as we've been diddling with it, maybe sometimes to Steve's chagrin, is to really look at adding a sort of HTTP referenceable homepage for every there's a proxy now for every collection and data object in iRods, and the ability to, in my mind, start marking up those pages with microformat RDFA or JSON LD representations. Honestly, that's as far as we can see because we're not smart enough to know. And we're also looking, put it this way, I'm not smart enough to know, I don't want to speak for the group, exactly where to go from there. Although I think what we're trying to do is really look for some cues from the NIH Commons in terms of how they want to approach linking data. And do we want to publish data into another larger repository for search and so forth. So where we are, I think, is looking at the enabling layers and trying to be smart enough at least to not have painted ourselves into a corner as these develop. I don't know if that's a fair answer, but.
So yeah, and to ease your life as a facilitator, as a services integrator, I could really recommend two of the big players in ontology services. One is the Ncbi Bio Portal service, where you can do lookups and use autocompletes in your web forms, for instance. What we use in Maastricht is the EBI counterpart of that, called Ontology Lookup Service, which we also have a Docker container for. So feel free to check out our GitHub and speak to me afterwards.
That's one of the reasons we introduced some of the folks and the staff is we probably would like to talk to some of you guys offline and see. So there are other people within our group that are more conversant in ontology management, vocabulary engineering, and that sort of point. So yes, let's talk offline. I would really like to learn.
Let's do that. Yeah.
Anyone else? Question? All right. Thank you.